G'day. Well, today we're going to look at the battery standards for Australia and New Zealand and try to understand the differences between a BESS, a battery system, and the other components within an installation. Okay, let's get into it. All right, well, today, as I promised yesterday, and this time I will actually get onto it, we will look at battery standards, in particular the joint standard with New Zealand, AS/NZS 5139. Now, the history behind this standard is that it was started a couple of years ago in draft, and it really was very, very overdue. We so needed a standard that replaced the previous one, which was really written for lead acid, nickel iron, and nickel cadmium batteries. The standard got published late last year, and has been enforced in Australia and is being sort of soft enforced, I believe, in New Zealand. It's a bit ambiguous how it applies. But my understanding is that Energy Safety say that if there isn't an existing standard, you should use all practicable means to make safe. And this standard is a practical means to make safe the installation of batteries. So kind of indirectly, even though it's not referenced to New Zealand electricity regs, it is actually applicable to New Zealand right now. Irrespective of any regulatory requirements, it is also a really good best practice guide on how to install a battery system, whether it's on-grid, off-grid, or just a dedicated load. So this is actually the Smart Energy Lab on top of Mount Tillybong, about 65k from Melbourne City in Victoria, Australia. This is an off-grid community of about 70 people scattered across 30 homes. What you're looking at there is my cluster of 7 homes, my neighbours and mine, and also my Smart Energy Lab in the rear. The lab itself actually runs a microgrid that supplies power to all these homes, and it's a two-way system, so the homes have solar and battery, but they're connected to a microgrid. So yeah, it's both a teaching resource, a practical resource, and it provides a service to the community. I've been getting a few questions about microgrids, and I realise there's quite a bit of interest. It is a growing area, particularly for greenfield sites. Is why bother even connecting to a grid for a new development? So I may be running, I'm very sure I will be, a few webinars on microgrids after this series finishes. Now, there's some links there, by the way. Thank you, Rachel, for typing those in. And also there's my social media. If you're into Twitter or Instagram, you can follow me on those two as well. So what we're talking about today is 5139. 5139, there's a picture of the cover. Now, it is in Australia, it is a copyright document. In New Zealand, there's in Australia and New Zealand as well. So I'm not at liberty to share the document, but you are capable of downloading it and purchasing it, from Standards Australia in Australia or from New Zealand Standards. And I believe that if you're a member of the ESWB in New Zealand, you can actually download it for free. So, sorry, I think I got the acronym wrong. So this standard was published in October, and as a result of that, it's kind of come into force in various ways. So let me just move forward on this one and show you the collection of standards that you need to consider. So here we've got 4 documents on the screen, and they really are the 4 documents that you need to consider when installing a solar and battery system. The battery standard 5139, the scope of that we'll cover in a second, but basically it covers everything after the inverter or charge controller, all of the DC side of a battery system. And if it's an integrated solution, such as a device that has an inverter built into the battery module, then it covers that as well. AS3000 always, AS/NZS 3000, covers installation of wiring systems, including DC, including off-grid and on-grid systems. 4509 Part 1 is the standalone system standard for installation, and so it covers the requirements for installing systems standalone. I should point out that standalone doesn't mean you live in whoop whoop. It doesn't mean that you don't have the grid. It actually means that you're capable of running whenever you wish, independently of the grid. So it may be that you have a changeover switch or a disconnection from the grid, and you are now a standalone system. The 4th document in that list, the best practice guide, is is kind of a strange concoction. It's a collection of other standards. It's not published by a standards organization. It's published and it's free. You can download it. Rachel might pop up the URL in the in the captions, but it's known as the Best Practice Guide. Best Practice Guide for Energy Storage. It was put together because we lacked an actual product standard for battery systems in Australia and New Zealand. And in lieu of a product standard, we chose to collect together many methods of meeting a high level of safety. And this document is co-authored by all those groups on the cover, and it is currently in version 1. Now, it's version locked to the standard, so 5139 references this document a lot, and I'll cover that in a second, and it's version 1 locked. So even if this document gets updated, it's still version 1 that we have to refer to. So I'll be chatting for a second. I see some questions have come in, Rachel.
Yes, one from Jonathan. In New Zealand, we don't have net metering. Is there a grid tie inverter storage solution for dynamically balancing so self-consumption can be maximised across 2 or 3 phases? Jonathan, that's got nothing to do with battery standard, does it?
Jonathan, I think you're trying to just pop in a few random ones there, but look, yes, New Zealand and I think either Slovenia or the Czech Republic are the only 2 countries in the world that meter in this strange way, which is in a 3-phase installation. They meter each phase independently and they don't aggregate them in real time. So if you're exporting on one phase, you get one rate for the power, and importing the other phases, you get another rate. They don't aggregate the 3. So it is a real issue for New Zealand and Slovenia and or Czechoslovakia that you have a design that considers that strange method of metering. So that's an explanation of standards compliance. We're going to look at these, the scope of 5139. Now, if you're not familiar with how standards work in Australia and New Zealand, the first thing you should always do is read the scope to make sure if it even applies to what you're doing. I remember when this standard was being in draft, a lot of people were concerned that it would be impossible to put a battery in a caravan, because one of the things the draft said is that you shall not put a battery in a habitable room, and there's nowhere that's not habitable in a caravan. But it turns out it's actually exempt. So transportable vehicles are covered by other standards, ASNZS 3001, for instance. So you only have to comply with that standard, not with this one for transportable vehicles. I jokingly point out that maybe if you put wheels on your battery, it's not covered by the standard, something like a car. Anyway, so let's go back to the top of that list. Nominal voltage range of 12 to 1500 volts DC. We're capturing a very wide range of battery systems there. It has to be a battery system that's connected to power conditioning equipment. I'm not sure why you would have a battery doing nothing, because if you don't use it for any purpose at all, power conditioning equipment by definition is anything that modifies voltage, frequency, or power, or current, sorry, and as a result, you connect a charge controller, an inverter, or even a load that runs off a battery that modifies it in any way. It is now power conditioning equipment. Connected to rechargeable cells, not primary cells. Primary cell is not rechargeable, so it's just a disposable cell, and capacities of 1 to 200 kilowatt hours. So we didn't actually want to try and capture large commercial and utility scale battery storage. So 200 kilowatt hours was kind of the upper limit in this scope. But I should point out that it's really only a recommendation. Any entity that requires compliance can choose for you to comply to the standard as well. So you might be installing a commercial energy storage system that's half a megawatt hour, and the utility might say, and we want compliance to the standard. So don't think you get out escape with just being out of scope. What are exempt, though, are critical power systems, things like hospitals, lifts, telecommunication sites, which have their own standards already, electric vehicles. So your electric car that you park in your garage can be parked in your garage, but ironically, you may not be able to put a battery in your garage because of the strict requirements. Now, don't take that as a given. We'll look at some of those location requirements. It doesn't cover portable equipment, so if it's not a part of a fixed installation, it's exempt. And if it's a UPS system for critical power supplies or essential power covered by an existing standard AS 62040, so it's not a grid paralleling system, it's just a backup system, independent, then it's exempt. And of course, transportable vehicles. I've tried to simplify this very comprehensive standard. Now, this standard has a lot of repetition in it. And the reason for that repetition is so that you can read the relevant section that you need to comply with. So you'll find that sections 4, 5, and 6 have a lot of repetition. I've shown here just the clause headings of all those sections, and I've put in brackets the number of subclauses. The bits in blue are what are known as mandatory risks. That means you must comply with these. Now, before I go down and explain these in any detail, I should define what those 3 sections refer to and what a BESS is, a pre-assembled battery or other. A pre-assembled battery energy storage system, or BESS, is something that has energy storage and PCE as a pre-assembled manufactured solution. And that would be, to use brand names, something like an Alpha ESS eStore, a Tesla Powerwall, a Sonnen battery. They are pre-assembled BESSes. It doesn't necessarily mean that it all is in one box, though. You can actually have a pre-assembled BESS that has several components, but the requirement is that there is no on-site manufacturer, that all components are supplied and tested by the manufacturer. They may come in several packages that you assemble on site, but you're not manufacturing cables, lugs, protection equipment. You're just connecting to the input and output terminals of that battery energy storage system, or BESS. So that's where the word pre-assemble applies. It's predefined by the manufacturer. The pre-assembled battery system, which is section 5 type, is really just a battery which has a, I should flag that pre-assembled BESSes are defined as lithium-ion batteries at the moment because they need to comply with the best practice guide as well. So to be in section 4, you've got to tick 2 boxes. You have to have a manufactured solution that includes the PCE, and that whole package is got a manufacturer's declaration of compliance to the best practice guide. So remember a previous slide, I said the best practice guide, if I just go back to that, was a collection of standards. It isn't a standard itself, and it refers to international standards like IEC 62619, UL 1973, and others. Those are means to achieve a high level of safety. And because it's not a product standard, it's not something that you necessarily get tested at a lab, the manufacturer needs to deem compliance to it. But within it, it has product standards. So ironically, a manufacturer to comply with the best practice guide probably has to achieve compliance for various substandards within that. So to be part of the best practice guide, you actually need to have a lithium-ion battery. And the reason I say lithium-ion is that currently the best practice guide only deals with lithium-ion batteries. I know this is a major concern for all those other chemistries on the market, but it was kind of like the first stab at trying to come up with a product standard.
Richard Hopkins jumped in. Is it at all likely that over time applications for BESS under this standard will change, such as a UPS function will be provided? If so, what will happen to this standard?
All right, so in terms of the development of standards, there's kind of 2 things that happen. A standard is published. It can be updated, but that's fairly infrequently. So that's often, every 3 to 5 years, depending on interest in the standard. Incidentally, the previous battery standard that this supersedes, AS 4086, which wasn't a joint standard with New Zealand, it was last updated in 1997. So it's been retired. There are amendments to standards, which is often used to fix problems or to tweak an existing standard. So generally, we're only allowed 2 amendments to a standard by Standards Australia before a new update must be initiated. I wouldn't hold your breath in terms of a complete update to 5139 for another maybe 5 years or so. It could be quite a while. The best practice guide is being worked on right now, so we may have newer versions of that, but we'll need an amendment to 5139 to reference any future versions of the best practice guide. And that is what would hold back, in terms of Richard's question, changing definitions of a BESS.
Jeremy asks, are there alternate standards for caravans and tiny homes? I think you mentioned that.
Yes, Jeremy. So there are existing standards for electrical installations on transportable vehicles, which would be tiny homes and caravans if they are transportable. That would probably mean they don't have a permanent connection to a grid or an earth stake and an MEN. They're actually have a floating earth system. They're covered by ASNZS 3001. For transportable vehicles. It doesn't have a lot to say about battery systems at all, and it often refers back to AS3000. So you could say it's still a little bit of a loophole at the moment in terms of battery safety, but that's the situation. Rachel.
Okay, yeah, there's a couple relating to location of batteries. Richard asks, wooden-clad, wooden-framed ski lodges, do all classes of battery, I see lead-acid lithium, have to be installed externally to the structure?
Richard, let me answer that with some diagrams. So in my presentation, I've actually got some diagrams, and I might actually jump forward slightly to those and then come back to that chart, because that chart's a bit of a head spinner to look at. So let me just bring up a diagram for you. Okay, so here's a little summary about where under this standard you can install a battery system or a BESS. Now, remember I said section 4 only applies to lithium batteries that are pre-assembled BESSes and comply to the best practice guide. So BPG is best practice guide. You'll see that inside a habitable room is no for all types, all categories of batteries. Can they be installed under the floors of habitable rooms? Yes, for section 4 and 5, but no for section 6. Now, I haven't explained sections 5 and 6 yet. I'll get to that. And you're talking about a ski lodge. Well, a ski lodge has definitely got habitable rooms within it. It may have some dedicated rooms that are not deemed to be habitable, such as storeroom, a utility room. But one of the overriding principles of 5139 is that irrespective of which section you're in, sections 4, 5, or 6, is if there is a habitable room adjacent to a battery system, whether it's a BESS or a battery system, you need a protection against the spread of fire. So all those ski lodges with wooden walls, if there is a bedroom, a lounge, a kitchen, a bathroom behind that wall, you're going to have to put up a fire barrier. It's a very narrow range of possibilities. Really, it has to be a lithium-ion battery because only best practice guide applies to lithiums. It needs to be a pre-assembled solution that the manufacturer has deemed compliant to the best practice guide. You can't do any on-site manufacture of components. It must be basically a fully tested product that you're installing. So like I said, a Sonnen, a Alpha ESS, a Powerwall, those are examples. A Vata, there's lots of them, is a pre-assembled BESS. Section 5 is where you have a pre-assembled lithium battery system that you connect to PCE, connect to an inverter or a charge controller. So that would be where you've got, say, an LG Chem battery or similar, which meets the compliance of the best practice guide requirements, and you connect PCE to it. And the reason why it's got a few more clauses is that you are doing some on-site manufacture now, which is you're selecting the cables that go between the battery and the PCE, you're selecting the protection for those cables, the location of them, etc. When you get to section 6, unfortunately, I call this the trash, even though some of the best products or safest products on the market might fall into section 6. It's because they aren't lithium. So for a start, anything that's not lithium goes into section 6, and any lithium battery that doesn't comply with the best practice guide or hasn't got a manufacturer's declaration to the best practice guide gets thrown into section 6. And it has the most onerous requirements. So you can see it's got a lot of no's there. There's not many places that you can install. I jokingly say, yes, you can put it in a bunker in the garden, but not within a building that contains habitable rooms. So that's a pretty challenging task for a residential install. So in the case of, I think it was Richard's question about a ski lodge, it all depends on what type of system you're installing, but definitely if that's a timber wall and the habitable rooms behind, irrespective of which section you're in, you're going to have to put up a fire barrier. Now, I think the next question will be, what's the fire barrier, Glenn? It's specified in the standard that it can be cement block, brick, concrete, terracotta tiles, or cement sheeting, or any product that complies with AS/NZS 1530 Part 1, I think it is, which is a fire standard for the protection against the spread of fire. And that's a very tough standard to meet, by the way. I tried to find some products that met 1530 and I couldn't find many. Ironically, even cement sheeting doesn't meet it, but we're allowing cement sheeting. So what I'm seeing already in Australia is people are using cement sheet as that fire barrier.
Mohammed says, I can see some systems that place the batteries under the solar panels on the rooftop. Is this accepted in Australian standard?
It actually says that part of the prohibited locations are on a roof unless specifically designed. So that's not a very detailed description, but the intent, because I'm on the standards committee, is that you have to consider loading. So if you're putting batteries onto a roof, so on a residential home, roofs generally aren't strong enough to take heavy point loading. But if this was, say, a car park building, it's the top floor of a car park, it's designed to take the weight of a vehicle. So surely a battery would be okay. So it doesn't specifically say you can't put batteries under solar panels, but it does say that unless specifically designed. So there'll be a weight assessment as part of that.
Okay. I'll go with 3 more. And we'll have the other ones we'll have to wait. Who did that? Waiting for Glenn to be here answering till they've posted. So how come, Jonathan asked, how come the fire barrier didn't go above the battery? Fire would go up to the ceiling.
Yeah, so there's always arguments that it's too much or it's too little, and we do have on the committee representatives of the fire services, and so they're experts in the spread of fire. And there's existing standards for buildings which have some reference to the spread of fire as well. So we used those in terms of the spread between floors of a building, etc. And so 900 millimeters was deemed to be the area of protection above a battery system, which is spacing between floors in a building, I think. That's where that came from. So it was initially going to be 1200 millimeters, and we kind of negotiated it down to 900. And it's 600 mils either side. So in summary, and I've got a picture of this coming up, if you put a battery or system or a BESS onto the surface of a wall, you're going to have and there's a habitable room behind. So I keep saying that it's about habitable rooms being behind that battery system. You then have this fire barrier that extends 600 mils horizontally and 900 mils above. And if the eave of the roof is less than 900, you have to line the eaves as well to 600 beyond the front of the battery system.
Okay. And does that apply to batteries like Simplify, which are enclosed in metal?
So because metal is not deemed to be a protection against the spread of fire. Now, some of you might go, oh, I thought it would be pretty good. It is for structural integrity, but it will still transmit heat. And this is where the expertise of fire services came in. They said, in the draft, we actually listed metal as one of the protective barriers that allowed. And they said, no, it will transmit heat very effectively, and so it can set fire to the wall behind the battery if it gets hot enough. So even if you have a metal battery enclosure and it's touching the wall, it's not going to protect that wall. It's just going to maintain the structural integrity of the battery system, not stop the spread of fire.
Jason just asked, is there a pre-assembled BESS for off-grid? I'm thinking no, and all off-grid would come under Section 5.
Actually, no, Jason, there are plenty of pre-assembled BESSs off-grid. Probably the most well-known is Tesla. Tesla have released their off-grid product, which is actually still the Tesla Powerwall, but with off-grid firmware. There are products in Australia. I'm familiar with the company Red Earth, who make a pre-assembled BESS specifically for off-grid. I think it's called the Drop Bear, a very Aussie name. So yeah, no, there are definitely pre-assembled BESSes. Manufacturers can make their own in a way. They can take products, and take the example of Red Earth with their Drop Bear. They're using Cellectronic SP Pro's Fronius solar inverters and LG Chem batteries, to my knowledge, the M48s, I believe. And they're putting them into a pre-designed package, a big metal enclosure, basically, getting it tested to IEC 62619, UL 1973, and the best practice guide, and selling that as a pre-assembled BESS. So I've actually been to their factory in Brisbane, and people are rocking up with a small truck and loading this BESS straight onto the back of their truck, and off they go to do a drop bear. It's a very simple install.
Suggestions: fire rated plaster, non-compliant or compliant?
I've been asked that before. So it's indoors, you may be able to find a fire rated plaster that meets AS/NZS 1530. You'd have to check if it does. Not basic plasterboard does. It's interesting, in the US, they actually require garages to be fire rated to a similar standard, but we don't in Australia and New Zealand. So if we had, we could have probably said any garage that met the building code of a certain date would be deemed to be a fire rated location, but no, basic plasterboard doesn't.
Okay, what about plywood with cement sheet over the top?
Yep. So the cement sheet gets you out of jail, basically. So you could have tissue paper walls, and you put cement sheet over it, and you've now got the fire barrier compliant with the best practice guide.
Okay, and all right, I've seen a forced ventilated battery room that was ventilated directly to the next door kitchen. Is there a stipulation in the standard on distant to adjacent properties?
Yeah, this has actually been in AS 486 for over 25 years, which is that where there are explosive gases being vented from a battery room or enclosure, that there is an exclusion zone around that vent. And the exclusion zone is 500 millimeters horizontally, 100 millimeters below, and up to the ceiling. So that is the whole zone. There shall be no sources of ignition or luminaries that aren't sealed. So if it's a kitchen, as long as the kitchen has equal ventilation to allow the gases to escape, and there is no ignition source in that exclusion zone.
From David Lamb, must lithium installed prior to the standard comply with the fire rating wall?
No. So it's not a retrospective standard unless your local authority chooses to try and make it retrospective. To my knowledge, in Australia and New Zealand, this hasn't happened. It's very unusual, by the way, for a safety standard to be made retrospective. Just think of seatbelt laws. If you had a car built in the 60s, you can still have a lethal seatbelt. But if you buy a new car, it has to have a compliant one. So here we're again looking at that comparison table. I just want to make the point that in terms of ease of compliance, Section 4 is the easiest because it has the least subclauses. And it sort of makes sense that if the manufacturer has gone to the trouble to make their product as safe as possible, have it tested to standards, and built something that you don't modify anything on, you just basically put it in place and connect it, the AC and DC inputs like the PV array or the grid, then it's got a high level of safety. The number of subclauses in the green section are the green section in general is known as variable risks, where these risks are based on assessment of that particular installation. So there might be mechanical, electrical, energy, fire, etc., explosive gases. There's a whole bunch of variable risks. For instance, if you have a battery system that emits no explosive gases, you can ignore that section or that subclause. When you get to Section 5, the middle column, you'll notice that there's quite a few more electrical subclauses. That's because of the installation of cabling between a battery system and PCE being inverters or charge controllers. And then you get to Section 6, which I say is the toughest to comply with because there is a lot of subclauses in all those variable risks. And also some of the environmental and location restrictions are a bit stiffer, which I pointed out already, so I'll go on to that. So I've tried to make a little flowchart for people installing a system, and I've put a brand in there just so you know what sort of thing we're talking about. So this example would apply to, for instance, a BESS, a pre-assembled BESS compliant with the best practice guide, such as a Tesla Powerwall, a Vata, Alpha ESS, Sonnen, etc. I'm just trying to think of all the brands I can throw up. They're not sponsoring me to say these words. I'm just trying to think on the top of my head. Those are all pre-assembled BESSes. So you have to check that they're compliant with the best practice guide. How do you do that? You need a manufacturer's declaration, right? So the manufacturer should provide you with a declaration that they comply with the best practice guide. So that means you go into section 4, and section 4 has mandatory risks for installation, the blue ones, electrical, energy and mechanical, and then they have some variable risks which are based on things like what type of chemistry it is and where it's installed. So for instance, the fire hazard is determined somewhat by location as well. If you go to a battery system that you are connecting to your own installed PCE inverter or charge controller, an example would be LG CHEM battery, for instance. It's a pre-assembled battery system, and by that it means it's got its own battery management system. It has its own integral safety systems built into it to protect it. That battery system, the other ones, I'm just trying to think of some brands at the top of my head. BYD, for instance, would also be in this category. It's got a few more requirements in terms of electrical hazards because of the requirement for cabling, and similar amount of fire and chemical and explosive hazards. So really sections 4 and 5 aren't tremendously different. Mostly it's about the electrical connections and protection of the DC cables. But it's when you get to section 6, which is anything that is not lithium and anything that is lithium but not compliant with the best practice guide falls into this. And now you've got a very large number of mandatory risks and variable risks to assess. Now I should point out that how do you make these assessments? The standard actually requires a risk assessment as a shell when installing a battery system or a BESS. And so there's a sample risk assessment within the standard. I mean, sometimes standards actually hold your hands. They provide you with examples and charts and tables, etc., that you can use, maintenance schedules, those sort of things. So I advise you to look at that risk assessment matrix that they provide in the standard, and it is a requirement. It is a requirement of the documentation too, that you have evidence of a risk assessment. And documentation, like with our other renewable standards, are mandatory. You can't just go, yeah, she's right, mate, it'll work. You actually have to provide an operating manual, a risk assessment, and in the case of battery systems, instruction to the system operator. That's a mandatory requirement, how to operate their system safely.
From Doug Harvey, will you have to bring an existing system up to the new standard if you modify, repair or add to it?
This will come down to your regulatory environment. So it depends, in Australia, which state you're in, or New Zealand, under which regulatory regime you fall. But general principles are that if you are modifying an existing circuit, this is general principles of AS/NZS 3000, you need to bring that circuit up to standard. Now, that can also be complicated by any rebate structure that you might fall within. So in Australia, with our small scale technology certificates, or STCs for short, modifying a system generally means bringing the whole system up to current standards, and that may be tricky because you might find that the inverter's not on the approved list, doesn't have a current 4777 Part 2 compliance. It can be a bit of a nightmare to modify an existing system. So I guess my word to you would be check with regulatory authorities first what the implications of upgrading an existing system. I mean, the obvious ones are, if you're increasing the power of a system, is the protection of the cables still adequate? And have you put it in a zone that would no longer be permitted? For instance, you're trying to upgrade a battery system in someone's bedroom. Well, no, you wouldn't be allowed to have it there anymore. So that's probably going to rule that one out.
Okay, and does that cover Jeremy's question, if you're replacing batteries like for like?
Once again, this really is a regulator's decision. It's not covered by the standard, but the principles are, if you're not modifying voltage or power, it shouldn't have an impact on safety, but also in the case of batteries, technology. So I suppose if the battery was the same brand, same type, but just a newer model, that's a like-for-like replacement. But if you're replacing a lead-acid battery with a lithium battery, it's a change of chemistry. So I would, this is my opinion, I would think that would trigger compliance.
So Munaz Ali asks, is there any place in New Zealand to install and test Powerwall BESS, similar place like Glenn's Energy Lab? I've got a new product coming in for testing.
I'm happy to accept products from New Zealand over here at my test lab. I have them come from all around the world, by the way. But no, I'm not aware of any in New Zealand, but please, if you do know of some, just pass that through in the comments or through the chat through to Rachel. It's good to know who's doing product testing. For those who didn't see the earlier webinar, we were referring people to the Battery Test Centre in Canberra in Australia, which is probably the most comprehensive test centre that I know of in the Southern Hemisphere. Rachel will put that in the captions. So it's the batterytestcentre.com.au. That's actually funded by the Australian government. It's installed by ITP Renewables, and it's online, and you can see battery systems that have been under test for many years. So it's a very useful resource if you want to compare products and product claims.
I think there's some confusion about definitions of BESS, but is it possible for a product like Redback to become a pre-assembled BESS, where the battery and inverter are still installed separately, but all leads are provided and it is a plug and play?
It already is a BESS. So it meets the requirements of a pre-assembled BESS. That means that Redback have designed a product, provided all the components. I've had a long association with Redback. I've got all the generations of their systems here at my lab. And when you install one of these, even though it comes in several boxes, there are no on-site manufacturer of components. So all the cables are provided, every screw and lug is already there, you're just screwing them together. So it is a pre-assembled BESS. So the important point to make here, it doesn't have to be in one box, it can be in several boxes.
Okay, and Anonymous says, I'm seeing installations where inverters are installed directly above power walls, 200 to 300 mil, on solar cutters. A photo of 2 Powerwalls and 2 Fronius was given the thumbs up by at least 10 or more installers. Do you see this one? Care to comment?
I suspect this relates to the clause in the battery standard that says that there shall be no appliances within 600 mils horizontally of a battery system that's not directly associated with that battery system. Now, it would be pretty obvious that the inverter that charges the battery is associated with that equipment. There's even requirements in terms of isolation, location of isolation for those pieces of equipment if they're associated with the battery. So there's no problem installing an inverter above a battery system. You can even put it inside the battery system if the manufacturer deems it to be okay. So take a Tesla Powerwall, the inverter is inside the battery system. But the manufacturer may specify clearances for other reasons, such as ventilation. So if the manufacturer says a clearance above of X, you still need to comply with that.
Glenn Harvey asks, can a BESS type system become reclassified as an appliance and therefore may not be covered by these standards?
No.
No, didn't think so. So one more. Why are the standards and the CEC, this is from Matthew Porter, so heavily geared to seemingly favour lithium technologies over other such proven tech as lead, where lithium can be a lot more hazardous than lead, sealed lead as opposed to wet cell?
Yeah, there's no, from my opinion, I'm on the committee, there's no underlying sort of evil motive here. It's really just the fact that there's a lag between product standards and in Australia and New Zealand and installation standards. And so we don't have the product standards that we can refer to for many chemistries. So sort of unfortunately, lithium's got in there early. There are some product standards, IEC and ULs, and that can be referred to. But this will probably be solved as time goes forward when product standards are produced. At the moment, there's a project in Standards Australia to produce a product standard for battery systems, for cells, for rating the capacity of a cell. So that's a move in that direction. We're expecting other ones to follow.
Just Raj mentioned fire rated fabric. I'm not sure if you're asking for a suggestion, Raj.
Actually, Raj, that's a really good point. There is a product, I know, I think LG Chem make a product that is a fire-rated product to equivalent to the standard. So I actually chatted them about it, but they said it's not UV stable or suitable for outdoor locations, and so it probably wouldn't be of much use for protection of batteries. But you can use a fabric as a fire-rated material if it meets the standard. So let's start looking at some of the specific clauses within 5139. Overcurrent protection, for instance, and this is actually a picture from my lab as an example of an installation of an off-grid system using simplified batteries and Victron inverters and charge controllers. You can't see the Victron charge controller in this picture. It's a requirement now that isolation of a battery system is ganged double pole overcurrent protection. In the previous AS 4086, it was possible to have individual poles protection, not ganged, but that's being changed. A big change, and it's tripped up a few people already, is that we've introduced a new voltage classification system. Now, in AS NZS 3000, we refer to ELV and LV. ELV, extra low voltage, below 120 volts DC and 50 volts AC. But in this standard, we drop that reference altogether to ELV and refer to decisive voltage classifications. Now, these are an IEC classification matrix. It's actually a matrix because it depends on environment, nature of the supply, is it AC or DC, and the voltage level. And we have adopted the requirements for a dry location. We deem that batteries shouldn't be installed at wet or damp locations, and therefore DVC A is systems up to 600 volts. So anything that's DVC A that doesn't go over 60 volts for more than 0.2 of a second under any operating condition is deemed to be equivalent to ELV. And in terms of licensing, that would mean that doesn't require electrical license, but it does need to be a competent person. And that's defined as they've gained the necessary skills and knowledge through training. So competent person can install systems up to 60 volts, but once you go over 60 volts for more than 0.2 of a second, you're in DVC B land. Until you get to 120 volts, and then you're in DVC C land. Now, DVC B and C are deemed to be equivalent to LV as defined in AS NZS 3000. So once you go over 60 volts on your battery, you've now got something that needs to have double insulated cables. It needs to be protected from touch to IP2X. You can't touch it with a test finger. It needs to be installed by a licensed electrician in Australia and New Zealand. So that is a big change from our previous standards, where we allowed you to go to 120 volts on a battery system without license requirements or double insulation. There's some extra requirements too for overcurrent protection devices. They're IP rating for indoors, IP23 for outdoors, IP56. So just make sure your product actually has got the correct IP rating. And there's a specification for any circuit breakers that you use on a battery system for overcurrent protection. Port classifications. Now, there's an example in this picture of a Victron MPPT, and that Victron MPPT can take up to 150 volts on its PV array port, but it's connected in this case to a 48 volt Simplify lithium-ion battery system. Now, because of the port classification, the port meaning the connection of an energy source or communication, if there is no galvanic isolation between ports, then the highest voltage present deems the classification of all of those ports. So you might have a PV array that's operating at, let's say, 100 volts, but a battery system that never goes above 50-something volts. But because the PV array is operating at DVC-B levels and there's no galvanic isolation between the PV array and the battery, we now deem the battery port to be DVC-B as well, which means that we have to have double insulated cables. We have to have adequate mechanical protection as per AS NZS 3000, and also that's licensed electrical work on that battery, even though it's a 48 volt battery, because of the DVC classification. So this is really something that is new to the industry, that non-galvanically isolated maximum power point trackers you need to consider the port classifications very carefully.
Hi, Glenn, from Nick Brody. That picture that you have, the off-grid one, Victron and Simplify from your lab, what class does this fall under? Does it comply? Where would you run the fire protection in that scenario, as most sheds and off-grid walls are built like this?
Okay, so that's a shed. There are no habitable rooms in that shed. It's a freestanding building completely separate from any habitable structure. So it doesn't trigger the requirements for protection against the spread of fire. So remember, it's all about habitable rooms. So even though that system was installed about 3 years ago, it would still be compliant. It would fall under section, let me think, section 5, sorry, because I believe Simplify batteries are compliant with the best practice guide. I don't actually have a list in front of me, so I can't confirm that, but I think they do, because they are tested to UL 1973, a very tough standard, by the way, for safety of battery systems. If you've ever read UL 73, the highlight is the fire test for a battery. You have to place it in a pool of hydrocarbon, think petrol, set fire to it, leave it for 20 minutes, extinguish it, and leave it for 24 hours, and it must still be safe. Now, if you can set fire to your battery in a pool of petrol for 20 minutes, it's got to be pretty safe. So I like that test. So that battery is compliant to that, but it's not a BESS because it's been constructed from components. So cables have been selected, etc. So it would be a section 5 if the battery system's compliant with the best practice guide, a section 6 if it wasn't.
Simon Seglinski asks, how is port classification worked out in relation to DVC A, B and C?
So to reiterate, if there is no galvanic isolation between ports, the highest voltage of any of those ports is deemed to be the voltage classification of connected ports. So it's an example of a maximum power point tracker. If your PV array is DVC B or C, but your battery is DVC A nominally, it's now lifted up to the highest category, which is DVC B or C, because there's no galvanic isolation inside that MPPT. Now, there are some MPPTs that have galvanic isolation. It's not that common.
Okay, Nelson South asks, why is the standard only relative to voltage and not to fault current, as well in relation to licensing?
It is voltage, after all, that is the most likely source of electrocution and electric shock. Current is about burns and thermal injuries, and there is a whole section, which I may have time to get through to, on arc flash and arc incident energy calculations. These are a requirement that you do for every installation, is you calculate the arc flash incident energy and the arc flash boundary, and that will determine the personal protective equipment required for installing that system. And it also deems whether it's even allowed to be installed in a residential installation. For instance, if you go over 4 cal per square centimetre, you can't install a battery system in a residential application. Now, I've actually produced a spreadsheet to help people do these calculations, which, now I think of it, I'll post to, it's free to use, I'll post to in the description field of today's webinar when it's uploaded to my channel later today.
Okay, and Hamish asks, do I need a dedicated battery isolator if there is an on-off switch on my lithium battery module?
Thanks, Hamish. A very common question. The answer depends on the nature of that switch. We do allow integrated overcurrent protection in a battery system if it is readily accessible. Now, a couple of other conditions: that it is load breaking, or should be if it's overcurrent protection, and that operates on both poles simultaneously. Now, the readily accessible one can trip up some products. If you need a tool to access that switch, then it's not considered to be readily accessible. The idea is that the homeowner, the system operator, hasn't got a toolkit with them. They're not a licensed electrician probably, and so they need to be able to turn the system off by walking up to it and operating that safety switch. If the If the switch is an electronic switch, now in the case of Pylotex, the ones I've got here, the US 2000 A's and B's, it's just a software switch. It's not actually an overcurrent protection device. So it's only switching off the electronics. It's not actually isolating the output terminals of that battery. So I'd still need an upstream double-poled isolation and overcurrent protection device. And if you had multiple battery systems, you would need to have some way of isolating that system easily, and that could be by multiple isolators adjacent, but they would need to be listed in the shutdown procedure as well.
Yeah, you still have to protect the cable between the battery and the inverter. So, okay, so IP rating. Say this connector is rated at IP56NW. What is the NW?
Yeah, NW, bit of an Australian invention, no water. So no one wants water in their isolators. Effectively, it means that if there is any possibility of water collecting inside an isolator, and that can be due to humidity condensing that moisture, so it's not like it's leaking, but you actually have a humid environment, which is pretty much standard. Anywhere you've got hot and cold cycling, you need to have some means of releasing that water. So it's usually a hydrophobic plug or other design features that allow water to escape that may collect.
All right, I'll just hang on, answering a cheeky question. Scott Thomas asks, if the battery bank is over 1 kilowatt hour in a 24-volt off-grid system, does this system fall under the current battery regulations? And can a non-licensed electrician work on or install this system?
Okay, so the requirements to comply with the standard has nothing to do with whether you're a licensed electrician or not. So yes, it's over 1 kilowatt hour and it's over 12 volts. So under both conditions, you would need to comply with the standard. The fact that whether you need an electrical license or not would deem to be by the voltage level. Now, a 24-volt system is below 60 volts, so that's a competent person under Australian and New Zealand standards requirements. So a competent person, I often say, is a gift to lawyers because it doesn't define a license, but it does define a level of knowledge that is deemed that you can do the job safely. So, if you ever got taken to court over something and you were not a licensed electrician, you may be cross-examined about how you gained the appropriate skills and knowledge. But as soon as you apply a device that has no galvanic isolation to that battery, so let's say you put a maximum power point tracker on there that's operating at 80 volts, and it doesn't have internal galvanic isolation, the fact that the open circuit voltage can go to 80 volts on the PV array makes the battery, your 24-volt battery, now DVCB, so it's licensed electrical work. So actually you modify the licensing requirement by what you connect to it. And as soon as you connect an inverter to that, of course the inverter is going to produce 230-volt AC output, so the output of the inverter will be licensed electrical work. Now, gee, time has really got away with us today. It's 1 minute to 12, and this is when we finish every day. So I'd just like to thank everyone for the wonderful questions that have come in, and I'll try and catch up on some of those that I promised that I'd put links to in the description of my YouTube channel. But I plan to continue with this because I see the standards compliance as the core component of this webinar series, and so we will pick up tomorrow at the same time where we left off. Today we made a stab at trying to cover the Australian and New Zealand battery standard 5139. There were a lot of great questions there, and so I ran with them. We didn't really cover all the material I wanted to today, so we're going to get into it again tomorrow. So I hope to see you back tomorrow, and we'll lead off from where we left today. Okay, see you soon.